Please see the link in the description to download a worksheet for this video. Mountain ranges like this are some of the biggest things on Earth. They can be over 5 miles high, thousands of miles long, and weigh trillions of pounds. In this video, we'll introduce a theory called plate tectonics that attempts to explain how mountain ranges are made, what causes earthquakes, and what moves the continents. We'll cover 3 main topics: Pangea, what tectonic plates are, and common tectonic plate movements. Let's start by looking at the world map. It looks like South America and Africa could fit together, and some of the other continents look like they could also fit together. Geologists suspect that 200 million years ago, the continents made up one supercontinent called Pangea. Then, very slowly, the continents broke apart. The reason the continents are spreading apart is because they're riding on enormous rocks which may be 60 miles thick and thousands of miles wide. Those rocks are called tectonic plates. Here's a world map showing the tectonic plates. You can see many of them carry entire continents and parts of oceans. One of the reasons we think the tectonic plates are moving is because of imaging data from GPS satellites. You or someone you know may have used GPS on a phone or other device to find a place. And in the process, the device's movement, shown as a red arrow here, is given by GPS satellites. Here is an image based on GPS data from NASA satellites showing the movements of tectonic plates around the world. All of them are moving, although often only by 1 inch per year. To understand tectonic plates and how they affect the Earth's surface, we first need to know where they are. If we could look inside the Earth, we would see many layers like this. For this video, we'll focus on just 3 layers: the crust, the tectonic plates, and the rest of the mantle. The outermost part of the Earth is called the crust, and that includes everything from the biggest mountains to the deepest ocean floor. The crust is very thin. For example, if the Earth was the size of an apple, then the crust would be as thin as the apple's skin. We call the land the continental crust, and that includes mountains and fields. We call the ocean floor the oceanic crust. The Earth's crusts ride on tectonic plates, and those tectonic plates slide along a special part of the Earth's mantle layer. As they slide, the tectonic plates move the continents and oceans. There are 5 types of tectonic plate movements that explain almost all of the land geology and ocean floor geology that we see. We'll start with transform boundaries, in which 2 tectonic plates slide past each other. When this happens on land, we can feel an earthquake and see a fissure between 2 pieces of land that moved in different directions. For example, the land above this fissure went towards the west, and the land below the fissure went towards the east. A famous example in the U.S. of a transform boundary is the San Andreas Fault in California. No new land is made, and no old land is destroyed. The existing land just moves in different directions, and only a little at a time. The Pacific Plate moves in a northwest direction relative to the North American Plate. When 2 tectonic plates move away from each other, that is called a divergent boundary. A well-known example is on the floor of the Atlantic Ocean between the North American Plate and the Eurasian Plate, and between the South American Plate and the African Plate. As the plates move away from each other, the continents that ride on those plates are also getting farther from each other. This is the explanation for why the continents are spreading away from each other compared to when they formed Pangea. The tiny gaps between the plates is being filled with new rock from the mantle layer that rises in the form of magma. As that magma rises from the mantle, it forms underwater volcanoes which may release some magma as lava that then cools to form rocks. Many underwater volcanoes next to each other can form underwater mountain ranges. The Mid-Atlantic Range is the longest mountain range on Earth, since it stretches from the North Pole to Antarctica. It's been around for millions of years. The ocean floor on either side of the ridge has been newly formed by new magma that is cooling. But ocean floor that is farther from that ridge is older, since it was formed many years ago. A divergent boundary can also happen on land. For example, Iceland is a small island located over part of the Mid-Atlantic Ridge, with much of the western half of the country on the North Atlantic tectonic plate and much of the eastern half of the country on the Eurasian tectonic plate. As the tectonic plates move away from each other, they are making a gap in the island. We call this gap a rift valley. The gap is being filled from below Iceland with magma from the mantle that then cools to form new crust. This means that Iceland is getting wider. Because a divergent boundary makes new crust, it is called a constructive boundary. When two tectonic plates move towards each other, we call that a convergent boundary. There are a few different types of convergent boundaries, depending on what type of crust is on each tectonic plate. We'll review 3 of these. If both tectonic plates are carrying continental crusts where they meet, that is called a continental collision. In this case, both continents will form mountains. When we look down at mountains from a plane, we notice that their peaks form parallel ridges. We can see this same effect if we have 2 towels and move them towards each other. They make wrinkles that are all parallel to each other. For mountains, we call those folds rather than wrinkles. This is the explanation for how the Himalaya mountains in Asia are being made. The Eurasian plate and the Indian plate are both carrying continental crust and have a convergent boundary. The Himalayas includes Mount Everest, the tallest mountain in the world, whose peak is almost 6 miles above the surface of the ocean. In another type of convergent boundary, both tectonic plates are carrying oceanic crust where they meet. This is called a convergent boundary with a subduction zone. That means that one plate goes on top and one plate goes on the bottom. The plate on the bottom is pushed down towards the interior of the Earth. We call that downward movement subduction. The subducted plate will melt as it goes deep inside the Earth. The region where the plates touch looks like a valley, but we call it trench. An example of a convergent boundary between 2 oceanic plates is near a U.S. territory in the Pacific Ocean called the Northern Mariana Islands. The Mariana Trench is the deepest part of any ocean and is more than 6 miles below the surface of the ocean. Because some of the Earth's crust is being destroyed when one ocean crust is being pushed into the Earth's interior, where it will subsequently melt, we call a subduction zone a destructive boundary. The last example of a convergent boundary we'll introduce is when one tectonic plate that is carrying continental crust then meets another tectonic plate that is carrying oceanic crust. This also makes a convergent boundary with a subduction zone. In this situation, the plate carrying a continental crust is lifted, which we call continental lift. The lifted continent may also develop a mountain range. In contrast, the oceanic crust and the part of the tectonic plate it is riding on is pushed down into the Earth's interior. That action is called subduction. An example of this type of convergent boundary is in the northwest coast of the continental U.S. A plate under part of the Pacific Ocean, called the Juan de Fuca Plate, is subducting under part of the North American Plate. We explain this action in greater detail in a separate video on American mountain geology. The boundaries of tectonic plates is where almost all earthquakes happen. Governments monitor these boundaries to give early warning signs to people. For example, this U.S. government website provides daily updates on the location and severity of earthquakes around the world. We measure earthquake severity using the Richter scale, which rates them from mild as 1 to severe as 10. You may hear this scale reported in the news as a way to warn people. You can see the Richter scale numbers along the left side of this page. Fortunately, we have learned a lot about how to make buildings so they can withstand earthquakes. We also have automated communication systems that can warn everyone of the phone, even if they're far from a city, radio, or TV. Volcanoes are also common along the edge of tectonic plates. Here is a world map showing volcanoes as small red dots. As with earthquakes, governments throughout the world monitor volcanoes using seismograph machines like these. This helps governments predict when volcanoes will be active, so they can then give people better advance warning as needed. And as we've seen, mountains are also common at tectonic plate boundaries. It often takes millions of years for mountains to form because the tectonic plates move so slowly. For example, the height of the Himalaya mountains, which includes Mount Everest, is growing by about ½ an inch per year. If you're interested in knowing about the theories on what makes the tectonic plates move, then please see our video about the Earth's interior. Here's a summary and some additional information about the topic we've covered. Please pause the video if you wish to read this. Please subscribe if you'd like to be notified of future educational videos we make. Thanks for your attention.